Okay everybody, welcome back. In this video we're going to work our way through the examples from the rates of change lesson. We'll start here with example 1. In example 1, the number of gallons of water in a storage tank t minutes after the tank has started to drain is Q of t equals 80,000 minus 8,000 t plus t squared. We want to find the average rate of change of the water in the tank over the first 5 minutes that it's draining. Key phrase here, average rate of change. And you guys have found average rate of change plenty of times before in your life. You know it by probably a different name, and that name is slope. So anytime we see the phrase average rate of change, we're really talking about just finding the slope between 2 points. So if we're finding the average rate of change over the first 5 minutes that it's draining, that means we want to find the value of Q of 5 minus Q of 0. Come on, pen, that's right. All over 5 minus 0. And so we go ahead and substitute 5 into Q of t and do the calculations, and when we do that we get 40,025. And Q of 0 is going to be 80,000. All over 5 minus 0. So that's going to be negative 39,975 divided by 5. And then I'm going to go ahead and calculate this out. Negative 39,975 divided by 5. I probably could have done that without the calculator, but it's negative 7,995. And my units, since the numerator is in gallons and the denominator is in minutes, that's gallons per minute. And so the average rate of change of water in the tank is that it is losing 7,995 gallons per minute. Alright, on to example 2. In example 2, we've got a graphical sketch. We're supposed to draw a secant line through the points A and B and find the average rate of change between the points. Now, a secant line is just a line that passes through a curve at 2 points. And to draw the secant through these 2 points, we'll go ahead and draw the line that passes through those 2 points. And then to find the average rate of change, again, this is a slope calculation. And so the average rate of change is going to be 292 minus 157 over 94 minus 52. That's going to be 135 over 42. Let's see, can I reduce that? It's 45 over 14. And that is our average rate of change, the line, the secant line through those 2 points. And again, I could boil that down to a decimal. Quick check here what 45 divided by 14 is. And so the average rate of change is approximately 3.214 units. Okay, that's example 2. Alright, now we're going to move on to example 3. In example 3, we're told that the number of gallons, we've still got this same number of water gallons in the tank, but now we're asking how fast is the water running out of this tank at the end of 10 minutes. And this is an instantaneous rate of change. And for now, when we're finding instantaneous rate of change, we're going to do that using the limit. We're going to, in order to do this, we're going to find the slope at 10. But I'm going to introduce this quantity h. And so we're going to find our slope formula is going to be Q of 10 plus h minus Q of 10 all over 10 plus h minus 10. Now, of course, these 10's in the denominator cancel each other out, and so I'm left with just h in my numerator. And so, that the limit as h approaches 0, And then I'm going to put 10 plus h into the function. So we've got 80,000 minus 8,000 times the quantity 10 plus h plus the quantity 10 plus h squared minus q of 10, which is going to be 80,000 minus 8,000 times 10 plus 10 squared, all that over h. And I want to simplify. I also want to put this in parentheses. And so let's see, I've got 80,000 minus 80,000. Those are going to cancel each other out. When I distribute here, then I've got negative 80,000 minus 8,000 each plus 100 plus 20h plus h squared minus the quantity negative 80,000 plus 100. And I've got a few more things that cancel here. These negative 80,000s and these hundreds cancel each other out. And so I'm left with the expression negative 8,000h plus 20h plus h squared all over h. And if I try to find this limit via substitution, I end up with 0 over 0, which is an indicator to me that I want to factor and cancel before trying to evaluate the limit. So I'm going to factor my numerator. I can factor an h out of everything. Oops. I'll take my h out of that term. Come on. There we go. Computer's running a little slow this morning. And then the h's from the numerator and the denominator cancel each other out. And I'm left with this being equal to the limit as h goes to 0 of negative 8,000 plus 20 plus h, which we can find using substitution. And we end up with negative 7,980. And again, my units, since my numerator is in gallons and my denominator in minutes. This is the instantaneous rate of change at time 10. That is how fast the water is running out of the tank, exactly at the moment when time equals 10. Alright, and that's the last example from this rates of change lesson. See you guys next time. Have a great day.